Next we're going to have our second professor for the night. Is he still here? There he is. Keith Conrad is going to come up for us here. Let's go.
You're not going to have an arrow. You're not going to have an arrow.
I just did have an arrow. I
Turning it on. It works.
Yeah, okay.
So,
So that's part of the...
I need a blackboard and chalk. Great. So, my so-called talent is just that I'm going to tell some math jokes, but not this stupid like Abelian grave stuff. So some of these are actually true stories. Others are jokes, and so the amount of whoops. Does that work? So the amount of mathematical knowledge you need to appreciate some of these will perhaps vary widely. So we'll see how it goes. So first I'll tell you what my favorite mathematical joke is, because most of them are groaners. Not what I'm going to tell you today, but most math jokes are. So mathematician and engineer go to attend a physics talk where the speaker talks about 26-dimensional space-time, and after the talk is over, the engineer is holding his head and he's like, "Oh, that was so confusing," and the mathematician says, "Oh, that was a great talk." The engineer asks him, "But I don't get it. How can you understand 26 dimensions?" And the mathematician says, "Oh, it's easy. You just think about in n dimensions and then set n equal to 26. Okay. So here's a true story. So when I was in grad school, there was a postdoc in the department, and so he freely admitted he didn't know anything about popular culture. And as an example of this, he was teaching a multivariable calculus class. Of course, most of the students didn't care about math. And so this postdoc, he was really surprised and excited one day. After class, he overheard some students in his course in the back of the room talking to each other very excitedly about the group U2. True story. Emil Artin was one of the most prominent algebraists of the 20th century. Now, Artin's family, Artin was from Germany, but his ancestors are actually from Armenia. Now, some of you might not know, so in Armenian, almost all last names end in IAN, like Kevorkian, Kardashian. So, in fact, actually, this is really true. Artin's family's original name before they moved to Germany was Artinian. So in fact, if they hadn't changed the name, perhaps these days we'd be speaking about Artinian modules. I have a few stories about language exams. So at Harvard, you have to take two language exams. Now, of course, usually it's very easy if you want to take the French language exam. The universal recipe is you just find a book by Sarah in French and English and you just compare. So it's pretty easy to pick up mathematical French and perhaps German or Russian if you've studied it. So Dick Gross, who's a professor at Harvard now, is my advisor. When he was a grad student at Harvard, he decided to take the German language exam. This is a true story. He decided to take the German language exam without knowing any German, but when he was growing up, his parents spoke Yiddish. So what he was going to do on the exam was if he ran into a point where he wasn't understanding the text, he would kind of just say it in his head and think about what it sounded like in Yiddish and go with that. So what wound up happening was, so it turned out that the text, you're given a one-page text and maybe an hour or two to translate it. So the text of the German language exam that year, which was being administered by Alfors, the text was about the work of John Tate, who was already Gross's advisor. And so at one point in the text, let me see if I get the German right. Let me see if I get the German. Whoops. Get the German right here. So I don't know how to pronounce German, Seite Arbeit von Tate. So it means since the work of Tate, ... and so on. So, is this correct?
Seit der Arbeit von Tate. It's der, not die. Yes, exactly.
Oh, this is incorrect?
Yes.
So what should it be?
Yeah.
ER.
Okay. Thank you. Now it's much clearer, right? Okay. In any case, so Gross comes across this phrase on the exam, and he reads it in his head, and so he's so absorbed by his plan to kind of say everything in Yiddish that he says it, sieht die Arbeit von Tata, and in Yiddish, Tata means father. So he translates on the exam, since the work of the father, ... So he fails the exam, he gets the exam back, and he's told he fails it. And they also tell him, we think you should reevaluate your relationship with your advisor. But it goes on. So after the exam, Alfors offers to Gross a chance to, as a makeup on the spot, he says, why don't you just go down to the library, department library, and just pick a book in German. Which book? Any book. So Gross finds Van der Waarden's Modern Algebra in German, and he goes to Alfors' office, and Alfors is sitting there, and Gross is standing there, and he says, open the book. Gross opens the book, and just translate it. And so Gross opens the book, he opens it up, he sees a theorem, he can read the beginning of it, let K be a field, the following conditions are equivalent. 1, K is algebraically closed. 2, every non-constant polynomial in K bracket X has a root, and there are 8 conditions equivalent to being algebraically closed, but Gross can't read the rest of it, but he knows lots of conditions equivalent to being algebraically closed, and he has the book. So he just starts saying, every polynomial splits completely, every variety over K has a K rational point, and so he just starts saying stuff, and Alfors passes him. So traditionally, the 3 main languages are French, German, and Russian, but in the late 90s, a couple of algebraic geometry students at Harvard petitioned to allow Italian as a language on the language exam, since Italian was the prominent language of algebraic geometry, or one of them, from the late 19th to early 20th century. So they did allow it, and I think on the first year that the Italian language exam was being given, there was a student who had been taking Italian, a real Italian course for personal reasons, so he decided to, he was a second-year student, decided to take the Italian language exam and just see how it went. And so he took the exam, and they gave the exam to be graded to Angelo Vistoli, who was a visiting Italian algebraic geometer. And so in the hallway, when he had the stack of exams, the sheaf of papers, I don't know. Anyway, so so he met crossed paths with one of the regular faculty and pointed to this student's paper, and he said, who is this guy? What year is he? And so he's one of our second-year students. So okay, good, I wanted to fail him, but I wanted to make sure it wouldn't affect his graduation. Because usually, if you wait until the end of grad school, you'll get passed out of your language exam. Okay, next story. Now, the prelims at Harvard are extended over 3 days, and while the students are sweating out the exams in the exam room, the department posts the exams for that day on the blackboard in the common room for everyone to see, so like this. So I just downloaded the 1995 day 1 the Harvard prelim, so there they are. Anyway, so they're posted on the blackboard in the common room, and usually people go up and they look at the exam, and especially the older graduate students, they always comment how so much easier the prelims are these days than when I had to take them. So to see how that, to kind of play on that, one year a graduate student decided to create, with the help of the department staff, to create a fake prelim exam with very hard or impossible problems on it, just to post in the common room to see what would happen. I mean, the students who were taking the exam had the real exam, but the staff typed up in the usual format an exam filled with impossible or very hard problems. And so, you go up to the exam and it'd be like, characterize the Fourier coefficients of an L1 function, or these things are basically impossible. And so, so the students are standing around, and Jean-Pierre Serre is... He's here!
You good? Did you unplug it? I don't know.
Maybe I turned it
No,
off.
is it still on?
Okay, so So, welcome back. Nope.
You gotta be gentle with it. Hold it higher up, maybe.
All right, maybe that's better. So, right, so Sarah was visiting Harvard that semester, and he comes up, the crowd of graduate students, he comes up and he looks at the exam, and so...
He's really here.
What is it?
You probably don't want to step on the cord.
Okay. So Sarah goes up, and so one of the questions on this fake prelim exam was about the higher homotopy group spheres. And, okay. So these are notorious...
You don't need the microphone out.
Yeah, so these are notoriously hard to compute. So the question had two parts. Part A was to define the higher homotopy groups of a topological space, or connect the topological space. And the part B was to compute some example. I don't know, the 24th higher homotopy group of S2. Where's Aaron? Where's Aaron? Is he here?
Yeah, he's right there.
Where is he?
You know,
No, of course not, okay? Right, you look it up on Wikipedia and you can find out. All right, so anyway, so question A, define the higher homotopy groups of the topological space, which is just a basic definition if you know it. And then part B was basically, an extremely hard problem to compute some, the 24th higher homotopy group of the sphere or something. Anyway, so Sarah comes up, he looks at these questions, and he turns to the graduate students and he says, so part A, I define them to be 0, therefore for part B, they are 0. That probably wouldn't help you if you were taking the exam for real. In any case, oops, where did my... that year, so Richard Taylor had arrived at Harvard after his work helping Wiles with Fermat's last theorem, and he was giving a course. And during the course, so there's a common notation. So ZP in number theory stands for the p-adic integers, not the integers mod p. It's not really so important. But in recent years, there's been an extension of that notation, some ring called ZP to the f. It's the integers of the f unramified extension of QP. It's not so important, but it's not some notation going back to the 1930s or anything like that. So this is somehow came into wider use more recently. So Taylor's giving his course, and at some point, he writes Z9. This is the integer of the quadratic unramified extension of Q3. So he writes Z9. This was not a notation that Sarah was familiar with. And so Sarah's in the audience, and he asks Taylor, excuse me, what is Z9? And Taylor answers, it's 3 squared. True story. So some of you might be wondering about my hat. So this hat here, so of course it's called a Z hat, and if you don't know, so Z hat is the name for a certain compact ring, and it's prominent in commutative algebra, especially number theory. And so this is sold by a high school summer program, the Ross program at Ohio State, and they call it getting Z hat. So one year there was a high school student who was wearing he always wore a Z hat, but then he lost it, and so he was going around asking about, have you seen my Z hat? I need my Z hat. And he actually said, I don't feel complete without it. This is a complete topological group. So the counselor started laughing, and he was like, what's so funny? Where's my Z hat? Right. Now, if you go to graduate school in the U.S., usually most of the foreign students you meet from France or Russia, they're also grad students, so you kind of get the mistaken impression that all French people and Russians are geniuses at math. Okay, so of course this is not true, but nevertheless one sort of gets this vague impression. So the first time this feeling was dispelled to me was I was in Japan, and of course if you think about Japan is close to the other side of Russia, and so I was in Hokkaido and I was walking around the campus and there were 3 Russian students there talking to each other, and so I went up and introduced myself, and when they found out I was a math professor, they immediately asked me if I could help them with their math homework. And so one of them posed some kind of differential equation. They were just taking a basic calculus class. And just to check on their understanding, I asked them, well, before I answer your question, tell me this, what's an example of a solution, what's an example of a function that's equal to its own derivative. And there was kind of an awkward silence, and then one of the students finally said, x? So I was like, oh, Russian and math, amazing. So, but then I realized later that even though, of course, he had no idea what he was saying, in fact, he was right. Because if you think about differentiation as a linear transformation and identify Rn with the tangent space at the origin, the linear maps that are equal to their own derivative are exactly the linear transformation. The maps that are the differentiable maps that are equal to their own derivative, exactly the linear transformations. It's like in one variable, f of x equals mx. It is equal to its own derivative in the sense of differentials. So in fact, y equals x, even though he had no idea what he was talking about, those math genes were at work and he was right. So by the way, if you didn't understand the math behind that, that would actually be something very useful for you to try to understand why linear maps are equal to their own derivatives in a high-dimensional context. I'm teaching a calculus class this semester, and Math 16A, and I have 8 GSIs working with me. And so during the grading of the midterm exam, first midterm exam, the way we kept track of who is grading different packets was somebody made a huge table on the board, maybe like the questions 1, 2, 3, and the sections 101, 102, 103, and so on. And every time somebody took an exam packet of the papers from a section, they would put a circle in there so you know who had the packet at that time if you wanted to find it. And then when you were done with the grading, you just put an X, and that's so that packet is finished for that question. So when the exam grading was all done, the board was full of circles with X's through them. And so I took a look at this. Oh, I forgot that. I took a look at this and I commented to the graders that I've never seen so many tensor product signs together in my life, but it's nothing to be afraid of because the board is flat. I don't know if a flat module behaves well with respect to tensor products. They're hard things. So I'll end with 3 jokes. These are jokes. 3 jokes that have unexpected extra punchlines at the end. So you might have heard them in a more standard form, but then there's an extra mathematician makes a comment afterwards that gives you a new spin on the joke. So for the first one, this is actually Anton's contribution. So there's a common, very bad joke about what do you get when you cross an elephant with a chicken. So who's heard this before? What do you get when you cross an... Okay, so what's the standard answer? What do you get when you cross an elephant with a chicken? Elephant, chicken, sine, theta, right? Like a cross product. Ha, ha, ha. So Anton has a much better answer. What do you get when you cross an elephant with a chicken? You get a trivial elephant bundle over the chicken. For the grad students there. Okay. But the next 2 are more basic. So the question, why is the play about finite abelian groups so boring? Okay, so the standard answer is because all the characters are one-dimensional. But when Jacob Lurie heard this joke, his reaction was, don't you mean because all the irreducible characters are one-dimensional? Yeah. So my final joke, so 2 mathematicians, they're fairly old, and they make a pact that whichever one dies first will come back and tell the other what it's like in the afterlife. And after one of them passes away, and a few weeks later, he manages to make contact back with the living mathematician, and he says, so the guy who's still alive says, so what's it like? What's it like in the afterlife? And the one who passed away says, well, I have good news and bad news. No, what's the good news? Well, the good news is that you get to meet all the famous and prominent mathematicians from earlier generations, Archimedes, Newton, Gauss, Riemann, Poincaré, and you get to talk to them all the time, and it's just wonderful. And we even have a regular seminar every week. And so the mathematician who's still alive says, well, that sounds great. What could possibly be the bad news? You're giving next week's talk. But there's an absolutely incredible follow-up to this joke. So when this joke was told once, He was told in the presence of Ofer Gabor. You know, if you've never heard of Ofer Gabor, so he's an Israeli mathematician at IHES in France, and he's very serious, and he's the kind of person who will say like, what about the empty set or the zero vector space? He's kind of very pedantic and very careful. So, and not much of a sense of humor. So a group of people, someone tells this joke, and of course Ofer doesn't react at all, and eventually people go away, and Ofer goes to sit down, but a few minutes later, he starts laughing, kind of out of nowhere. And he was like, what are you laughing at? So I finally understand that joke. It's like, oh, what's funny about it? Just think about it. If you have to give a talk in front of Riemann and Gauss, I mean, they're going to put you through the ringer. It would be terrible.